Dear students, welcome to the online course of Object Oriented Programming of the Kohat University of Science and Technology. In this lecture, we will continue our discussion of inheritance, and we will be focusing on overriding. And this will be lecture 11 of week 5 of the course. So let's continue with the lecture. The agenda for this lecture is the continuation of our understanding of inheritance, and as I said, that we'll be focusing on method overriding and maybe possibly the object class later in this video. Previously we have been talking about an introduction to inheritance. In our previous two lectures we had an introduction to the inheritance, and then we discussed the behavior of constructors in the context of inheritance, and we tried to understand how the behavior of constructors will change when we use inheritance. We also talked about the public, private and protected access modifiers, and of course the chapter for this lecture is chapter 9. The book that we have been using is Detail and Detail Java How to Program Early Objects version. You can follow some of the tutorials, online tutorials that you can find useful, and some of the relevant concepts that you can, if you want to go into the details of inheritance. And of course in the future lectures you will be going into the concepts like polymorphism and hiding fields, etc. And we'll be talking about using the super keyword in this lecture as well. Method overriding. By method overriding we mean that we can change the meaning of a method that is declared in the superclass. We talked about inheritance, and we said that we can inherit some or part of the superclass, and that can include the methods as well as the data members of that class. And when you try to inherit, let's say, a method, we can possibly change the meaning and the functionality of that method in detail. Let's say if you want to add something to the functionality of an existing method, then we can do that, or we can completely implement that method from the scratch. Like we can add complete new details to that method. We will inherit the method, we will override the method, and we will use the name of that method, but the implementation inside that method will be completely new. And we also understand that we can add functionality to the existing functionality of the method as well. And for this we will be using the super keyword. So what happens is that when we override a method and we want to add to the functionality of the method, so what we will do is we can call the method inside our the overridden method, and we can call the method the superclasses method by using the super keyword. And we will see this in the examples in this video and in the upcoming videos as well. There are some rules that we need to remember whenever we are talking about in overriding, or whenever we are trying to override a method from the superclass. And some of the main details are that we cannot override a final method. So if a method has been declared as a final in the superclass, that method cannot be overridden in the subclass, and the overridden must have the same arguments as the inherited method from the base class. So if you are trying to override a method, the signature of the methods should match, and by the signature we mean the name of the method and the number of arguments that are there in the superclasses method should be the same as the number of arguments in the subclasses method. So for example, if you are trying to inherit the method, and if we change the name of that method, we won't be able to override the method. And if we change the number of arguments that inside that method, we won't be able to override that method. In fact, the compiler will consider it as a completely new method instead of an overridden method. So we need to be careful about these rules once we try to use overriding, and we will see these in the examples in this lecture and in the upcoming lectures, that what are the things rules that we need to follow when we are using method overriding. And these are two of the most important of those rules. This example, it just tells us that if we even try to override a final method, we will not be able to do that. We cannot override a final method from superclass. So these will be two different methods, but the method will not be overridden in the subclass. So final method cannot be overridden. Final methods cannot be overridden, as we can see that this will not work. This overriding should not work. If you try this and run this code, you will see that this overriding does not work. The override a superclass method, as we said, that a subclass must declare a method with exact the same signature as the superclass, and we have an annotation for this. If we want to check, keep a check on our subclass that it is overriding exactly the same method, we can use the override annotation with this @ symbol. We can use this annotation with the name of a method. In that case, the compiler will check if we write this annotation with a method in our subclass. The compiler will make sure that we are overriding a method that exists in the superclass. And what it will do is it will check the signature of the subclass's method, and it will check the name of the subclass. It will check the number of parameters in the subclass. It will check the return type of the subclass and the access modifier as well. You can try this. You can try and we'll see this in the example as well when we discuss the examples for this lecture. We'll see this, that if when we use this annotation, the compiler will make sure that we are overriding a method. If we do not from the superclass, if we do not use this annotation, this override annotation, the compiler will simply consider the method in the subclass as a separate method, as a completely new method. It will have no link with the superclass's method. So if you want to ensure that we must override the method, and if you do not want to make any changes by mistake or intentionally in the subclasses method, in the signature of that method, then we can use this override annotation. It will take care of the overriding, and that our overriding of the superclasses method goes smoothly. Now what does it do? It indicates that a method should override a superclass method with the same signature. So the function of this annotation is simple. It ensures that we are overriding a method, and if we are not, then it will display an error. If it does not, a compilation error occurs. For example, we have this method in the superclass. So we can see the signature of this method, the access modifier, the return type, and the name of this method, as well as the number of parameters in this method. And if we are trying to override this method, public void method, the return type, the access modifier, and the number of parameters, these are exactly the same in these two methods. So we can say that we are overriding this method from the superclass. What if we want to ensure? We can write an override annotation over here with this method, and it will take care of the overriding for us. Up here, if we make a mistake, then the compiler won't know that we were trying to override a method from the superclass. But if we use the override annotation, then the compiler will take care that if we are using the exact same signature, and if we are not using this override annotation, the compiler will consider it as a separate method from the one that is in the superclass. So if we want to ensure, we can override use this override annotation with the name of the subclasses method right on top of it, and we'll see this in the example as well. Apparently there is no difference between these two methods, and what should happen is that when we call this method, it should display this, that is in the superclasses a method, and followed by this print message that is in the subclasses a method. So let's see the method. This method defined by the subclass is overridden to the method defined in the superclass. The method is called. We have declared an object of the subclass, and we call the method. Now this method exists in the superclass as well as in the subclass, and we'll see which method is called. So the call is generated to the subclasses method. So we have overridden this method, the subclass, the superclasses method. We have superseded that method, and the message that is displayed over here is that the subclasses method will be called. Placing the keyword super and a dot separator before the superclass method name invokes the superclass version of an overridden method. As we said earlier, that if you want to differentiate between the superclass and the subclasses method, we can do that by using the super keyword. And how do we do that is we write as super followed by a dot and followed by the name of the method in the superclass. So if we have two methods with the exact same name in the two classes, in the subclass and the superclass, we can call the superclasses method with the help of the super keyword. So it will be like a super dot the name of the method, and the name of the superclasses method will be called. And why do we need to call a method from the superclass or any other method? The reason for declaring or calling methods is that if we need a code, instead of rewriting that code, we can just call that method. If a method performs all or some of the actions, so if the method performs all the actions that we need in another method, we can simply call that method. But if we need some of the actions that that is performed by the method, then we can override that method. We can make changes in that method, and we can add to the functionality of that method. So instead of rewriting that code, we can simply call that method in maybe in the subclasses method or anywhere we need that method. So again, we have a superclass with the method add, and we have a subclass that of that superclass with the exact same method add. The names of the two methods is exactly the same, so the signature of the two methods is the same. You can safely say that this method is overriding, the subclasses add method is overriding the superclasses add method. But what we are also doing is we are also calling the superclasses add method inside the subclasses add method, and we said that we can do that with the help of the super keyword. So the super dot followed by the name of the method in the superclass that we want to call here. What should happen is now when that method is called, the functionality of the superclass method should be executed first. In this case, it is a sprint method, followed by the functionality is, we can see that the call is generated before this functionality of the subclasses method. Then the functionality of the subclasses method should be executed. We declare an object of the subclass, and with the object of the subclass we call the method of the subclass. We assume that we are calling the method of the subclass, but when the method of the subclass is called, what should happen is that this call should be executed right after the call to the this method, and whatever the message over here or whatever the functionality over there is, as you can see, first we need to create an object and then call a method with the help of that object. The second thing, a call will be generated to the superclasses add method from the subclasses add method with the help of the super keyword and a dot separator. So we need to remember that we can call the superclasses method, and if these methods have exactly the same name, we have exactly two methods with exactly the same name in the superclass and the subclass, we can differentiate between the two by adding the super keyword and a dot separator. So this one is the super keyword superclasses method, and this one is the subclasses method. Use super dot method name to call the method defined in the superclass. If it were of a different name, and we have seen that previously that we can directly call the methods of the superclass and the methods of our subclasses. So if it were of a separate name, then we did not need to use the super keyword. But as we can see that these are exactly of the same name, then we need to use the super keyword and a dot separator to call the superclasses method. As we said that the superclass functionality of the superclass will be super methods add method will be generated because that is called before any functionality for the subclasses add method has been added, which again is a print statement. So we can see that the print statement of the superclasses add method is displayed first, followed by the print statement of the derived or the subclass. So we can see that we can use the super keyword and the dot separator to differentiate between the methods from a superclass and a subclass. Let's look at an example. We have seen that how we declare an object. So we have this relationship between two classes. We have a sphere class and we have a colored sphere, which is the subclass of the sphere class. And we have seen that how to we declare an object of any class. So this is like usually we normally create an instance or an object in this way. Type of the variable on the left hand side is the same as the type of the variable color sphere created on the right hand side. By basically mean that these two types are exactly the same. But when we use inheritance, we can also, a color sphere object is also a sphere object. So we said that there is a relationship between the subclasses. So a color sphere is a sphere, and we'll see that we can call the constructor of the subclass through the superclass. We can assign like type of the variable at the left hand side is the sphere class, the superclass, and this on the right hand side this is an object, a colored sphere class. So we can assign the subclasses object to the superclasses object because the subclass object of the subclass is an object of the superclass, and we have seen that previously, or we have discussed this, that since the object subclass is the superclass, there is a relationship between these two classes. So you can say that a color sphere object is also a sphere object, and it is also an object which is the superclass class of every class in Java. So in this case, the object class is a superclass of the sphere class, which is then a superclass of the colored sphere class. So we can declare the object of we can create an object of the colored sphere in these three ways. This one right here, the type of the variable on the left hand side is the subclass itself, like the color sphere, and it is the same on the right hand side as well. But we can see that we can also declare the subclasses object using the superclass, or we can declare the subclass object using the superclass of the superclass. And we have seen this relationship previously, that we can derive a class. For example, the superclass does not explicitly is derived from any other class, but we know that any class in Java which does not explicitly derive from a superclass implicitly is derived from a superclass that is called the object class. And we'll see these in our examples in the future as well. So for example, now if we print these three objects, this will call the subclasses toString method. We need to understand that although this object was declared using, this was created using the subclass, that is the colored sphere class, the object S2 was declared or created using the sphere class over here, and this object obj1 was declared or created using the object class right over here. But when we print these objects, all of these will call the method, the toString method of the subclass, and this we'll see again in the example as well. So for example, we have three methods of the same name in these three different classes, and if we are using an object of the subclass irrespective of the fact that we what was the type of the variable on the left hand side, if it was a superclass or a subclass, the subclass's method will be called, and we'll again try to explain this with the help of an example as well. So if we see that S1, S2 and obj1 were declared using three different classes, and all of those classes have an inheritance relationship between them, then the method of the subclass, the toString method of the subclass will be called. But here, if we see at this object S3, now the S3 on the right hand side and on the left hand side, both of the type of this variable or this object is sphere. In this case, the toString method of the sphere class should be called, because now we are not using the subclasses constructor, we are not generating the subclasses constructor, and we should also know that the object of the superclass is not an object of the subclass. The reverse is not true. We understand that the object of the subclass is an object of the superclass, but the reverse is not true. The object of the superclass is not an object of the subclass. And we should also know that, for example, there is a method that is exclusive to the subclass. For example, there is a method in the colored sphere class that is not present in the sphere class. Then we will not be able to call that method through the object of this superclass. Can only call that method through the object of the subclass, and we'll see this in the example as well. Now, based on the previous discussions that we had in this class and the previous classes, this is an exercise that we can maybe try, and let's say what shall be the values of these variables for each of these objects. For example, what is the value of x for a1, for a2, and for b1, and so on and so forth. You can post your answers in the comments or maybe in the questions on KCMS, but do try and run the code, or do try to first write the answers and then try to run the code before you after you have written the answer, so you can then compare your answers with your code. This is another example that you can try. So we have a class called funCar that extends another class that is a car class, and we have seen that we can call the superclasses constructor implicitly if we do not have, like for example, we have a zero argument or a zero parameter constructor, then it will call the superclasses constructor zero parameter constructor. Then we have another constructor that should call, which is calling the superclasses constructor that takes two parameters. And then we have a method that displays a message when it is called, and it returns a string. So it should return this string whenever we call this method. All of these are given. We just need to try and write the output of this this code. So we have this superclass called car. There are a bunch of variables, and there are a couple of constructors, a toString method, and here we have the subclass of this class, and these are like the the objects, and you can go through this code and you can try and write the output for this class in the questions or comments. Now here we will have a closer look at the object class. We have said that any class or every class in Java that does not explicitly inherit a class is implicitly inherit from a built-in class that is called the object class. So this is how it usually works for any class in Java. If it does not have an explicit superclass, then it is implicitly derived from a superclass called the object class. Every Java class has object as its superclass and thus inherits the object methods. And whatever their methods are there in the object class, those methods will also be inherited by whatever the class that is inheriting from the object class. And we understand that object class is non-abstract. Now we have not studied abstract classes in this course yet, but we will be studying abstract classes in detail in the upcoming lectures. But simply we can say that when we say that object class is a non-abstract class, we can say that we can create an object for the object class. Abstract classes cannot have objects of their own because they are incomplete, they are abstract, they are not complete without their subclasses. So object class is a complete class in itself, and it has its own methods, but maybe the implementations of those methods are not particularly useful for us, but we can inherit those methods, we can override those methods, and we can add something useful to those methods. And we have been doing that so far. When we use the toString method, the toString method basically is declared in the object class, and what we do is we inherit that method, we override it in our subclasses, and we add something of our own liking to that method. So we use it to display the details of an object in the format that we prefer. In most cases, it is a good idea to override these methods with more useful versions. There is another method in the object class, that is the equals method. The equals method compares two objects for equality and returns true if they are equal and false if they are not equal. So it returns a boolean value. It will return a true if the two values are equal, whatever the two objects that we are comparing are equal, and it will return a false if those objects are not equal. The equals method also comes from the object class, and the toString methods, we understand that it also comes from the object class. And the toString method, it returns a string representation of the object, and we have been doing this from our earlier lectures. We have been using the toString method to print the details of our objects in the output window. So for example, the class object has these two methods. The equals method, which compares an object with the current object, and then there is toString method, which will by default, if we do not add our own return statement to the toString method, what it will do is, you can try this as well, it will print the name of the class. It will print the name of the class by default. If you print the object without adding anything to this toString method in our subclasses, it will basically print the name of our class. The toString method, and we understand that as we have been using it from our previous classes, it is intended to return a readable textual representation of the object upon which it is called. This is great for debugging. If you remember, we had a date class, and from the date class we were trying to print the date in a certain format, and then we were using that object of that class in other classes as well. So for example, once we had that class, we used the toString method to set a format for the date class, and we were able to print the date in exact that format in our other classes as well. So we only needed to debug that code once, and then we were able to reuse it in our other classes like the employee class without further debugging the date class code again and again. It returns a string, as we have been seeing that, like for example, we were if you were trying to print the details of the date class, you were trying the string format specifier for that. We were using the string format specifier because the toString method returns a string representation of an object. So for example, the three variables of the date class were integer, but once we use the toString method, the date was being returned in the string format. So we have seen that we do not explicitly call the toString method, and the reason for that is once we print the object, the toString method is of the class that the object belongs to is implicitly called, and the details are displayed. Called implicitly whenever an object must be converted to a string representation. And we have seen that, and we have been doing that. We do not, even if we do explicitly call it, it does not make any difference to the output of the object. Like this, we can simply print the name of the object, and it will call the toString method of the object of the class implicitly, and the details of the string representation of this object will be displayed on the screen. Every class has a toString, even if it isn't in your code, and you can write this. If you print an object, it might possibly print the name of the class that the object belongs to. The default, and you can try this, the default toString returns the class's name followed by a hexadecimal number. You can try this code by removing a toString method from any of your classes and then printing that object of that class, and you can see what is printed on the screen. What we usually do is we replace the default behavior of the overriding by overriding to the toString method, and we add something of our own to it. We usually add a return statement because it is always supposed to return a string value. We add our own string statement over here and try to return in the details of our objects in a format that we like or that we prefer. So to change the default behavior of toString method, we can simply change this return statement over here, and whatever there was, as we have seen in the previous slide, this default behavior will be changed to something that we want to do with the method. The equals method, on the other hand, it returns a boolean statement, a boolean value. By default, equals and it has a parameter of type object. Does exactly what the equality operator does: compare object references. That is, two objects are the same if they point to the same memory. It tries to compare the objects, and if they are equal, it will return a true, and if they are not equal, it will return a false. We will revisit the equals method in the strings when we study the strings, but here we will look at an example of the string and have a look at the equals method is what it does, because this is a method in the object class. Since Java does not support operator overloading is supported in C++, but Java does not support operator overloading. You cannot change this operator. However, the equals method of the object class gives you a chance to more meaningfully compare objects of a given class. So basically, we can compare the objects of a class. For equality, if they are equal, we should have a return statement that is a true if they are actually the same object. So for example, we have this object of the sphere class sphere1, which has been initialized, declared, and there is another object which has been initialized to sphere2 to sphere1. Now this is how the equals method works. It is called on an object. In this case we call it on the sphere1 object, and we pass the other object, and it will compare these two objects. Sphere1 will be compared to sphere2, and if they are the same, then the same should be printed, and if they are not the same, then this other statement different should be printed on the screen. And here we see two objects. Sphere1 initialized to created using a certain value, and a sphere3, and they are compared exactly the same way as we did for sphere1 and sphere2. Sphere1 and sphere3 are compared using this statement. Sphere1 we call it on sphere1, and we want to see if sphere3 is equal to sphere1 or not. In this case, since we were initializing sphere2 to sphere1, they are exactly the same, but here they are completely different objects because they are pointing to different locations in the memory. So they are not the same objects, they are different objects. To override, simply override method with version that does more meaningful test. Compare values and return true if equal, false otherwise. So what we did was we added some statement to our equals, and then you are able to display if they were equal or not. An equals method that determines whether two, for example, there is another example which tries to compare if two spheres which are objects of the sphere class have the same radius or not. So we can compare the two values inside the two objects over here. Again, this code, the equals code, the equals the method of code, and we'll see over here that we are trying to check if, for example, since this object is a superclass, and we said that it can possibly contain objects of the subclasses, references to the objects of subclasses as well. So if we want to ensure that if this object, that is like the superclass's object, is an object of the subclass, in this case the mySphere, we can use the instance of keyword which basically checks if this object RHS is an object of the mySphere class. If it is, then it will try to downcast this object to the object of the subclass so that it can compare the two. So here the object of the superclass is converted to the object of the subclass. We call this downcasting, and we'll see this in detail in the upcoming lectures. But we need to understand that when an object of the superclass is converted to the object of the subclass, that is where, and we need to do this because, as we said earlier, that if there is a method in the subclass and that method is not present and that method is not overridden from the superclass, then we cannot call that method using object of the superclass. So for example, if we need to call the object of the method of the subclass, we need to convert the superclass's object to the subclass's object, and this process is called downcasting. And we'll see this in the future as well. So now we have this object sphere 1 and this object sphere 2, and we are comparing them for equality. Again, now we have this object sphere 1 and sphere 3, and we are comparing them for equality, and now we'll see that if the two objects are the same or not. In this case, the two objects are the same because it has been converted to the subclass's object, and we can see that now they are pointing to the same location in the memory. Consider the equals method. Return, for example, this method. What we want to do is we wish to implement equals for my sphere, which gives us value equality. Specifically, two my sphere objects should be considered equal if their radius or radii are the same. So sphere 1 that equals new point sphere, whatever the values are we passing to as an argument. So we need to confirm if this parameter is an object of the mySphere class or not. So this is what we are trying to check over here. First we need to confirm that if it is an object of the mySphere class or if it is not. Now if it is not, the equal method should return false. If it is, with the instance of keyword we have seen that we can check that the object is a mySphere object. Next we need to get the radius from the parameter object for comparison. However, the signature of the equals method is the type of parameter object is object. It does not have any information regarding to this is another object. So we need to convert this object, the radius object, to mySphere first, then we'll able to then we'll be able to compare these two objects. So the type of parameter object is object. It does not have any information regarding to the radius. As we said that, for example, if we try to call method that is in the subclass but that is not there in the superclass, or then there is a variable that is in the subclass but is not there in the superclass, then we won't be able to call that method with the object of the superclass. In that case, we need to convert or cast the object, the superclass object, into a subclass object. So we need to access mySphere instance variable, so that's why we cast obj to a mySphere object. This is what we are doing over here in this line. We are calling casting or converting this object into a mySphere object, and we are storing it over in this object, which is already an object of the mySphere class, and we will confirm this using this statement, the instance of statement. So if they are the instance of, again we can check that the object is a mySphere object, obj is a mySphere object, so that doing the cast doesn't fail. We need to confirm that this object was created using a call to the mySphere class, and then we shall be able to convert it into an object of the mySphere class again. We'll see this in detail in the example when we cover the example of for this code, maybe in the next lecture. And this can be a general form of this code. It converts the obj object into mySphere object. So finally, if we want to revisit as to how super keyword and this keyword are used, We have seen that a super keyword is used for generating a call from the subclasses constructor to the superclasses constructor. It can either be empty with no arguments, where it will call the zero parameter constructor of the superclass, or it can have some arguments where it will call the superclasses constructor that takes some parameters. It can we have seen this that it is automatically called in the derived class constructor if it is not explicitly called. We understand that the constructors are not inherited, but we need to call the superclasses constructor the first thing there in the subclasses constructor. Automatically call in the derived constructor if not explicitly called. If you do not use the super keyword, then in the subclass constructor it is implicitly called. We understand that the call to super must be the first call in the subclasses constructor. We cannot do this. Super we cannot call the constructor of the superclass by name. We can only call the superclass constructor by using this keyword. We can also call a member, which can be a method in the superclass, or it can be a variable from the superclass, but we can call the members of the superclass using the super keyword. So it can be any method in the superclass or a variable declared in the superclass which is accessible in our subclass, and we can call those using the super separated by keyword separated by the dot. Members can be either method or instance variables. Refers to the members of the superclass of the subclass in which it is used. So if we want to use the superclasses members somewhere in our subclasses, then we can call those in the using the super keyword. We should note that a variable that has the same name as a variable in the superclass hides the superclass's member variable. So for example, we have two methods with exactly the same name in the superclass and the subclass, and if we use that name, what will happen is that it will call the subclasses method, and the superclasses method will be hidden under the name of the subclass method. So if we want to use the superclasses method, we will need to call that method using the super keyword separated by a dot operator, and the same is the case for a variable as well. The variable in the superclass cannot be referenced by its name and must be accessed through the super. So in that case, if we have variables or method with exactly the same name in the two classes, in that case we will only be able to access the superclasses method or variable using the super keyword. Otherwise, the subclasses method or variable will be accessed instead of the superclass. Use from anywhere within a method of the subclass. So we have seen that we can call the superclasses method from anywhere in any method of the subclass or the constructor of the subclass. This keyword, we have been using this keyword from our earlier classes, and it can be used inside any method to refer to the current object. We understand that this keyword is used to refer to the current object, and we have seen it is being used in the constructor. In that case, it refers to its own constructor. So for example, this will refer to the empty constructor, and this will be it will initialize any values that there are in the constructor with the values that we pass as arguments in the between these two brackets. and you can see that in one of the examples that we have discussed in a lecture, in the previous lecture. We can again this dot member, we have been using this to refer to our instance variables, and we usually do this. We can also do this with the methods. We have been doing this with the instance variables, and we usually do this to avoid maybe namespace collisions. For example, if we have two variables with exactly the same name, and we have seen that local variables that usually take precedence over our instance variables, and local variables are the variables that are defined inside some of the methods. So in that case, if we want to differentiate between the two kinds of variables, we can use this keyword with the instance variables, and these will refer to the variables of the current class that we are in. This concludes our lecture 11. It was about method overriding, and this will hopefully conclude our discussion of the inheritance. We will discuss an example of inheritance in the next lecture. You can try this exercise maybe, which tries to compare these two objects of the book class, and want to compare these for equality. So first you will need to convert this object, for example this, into, first you will need to check using the instance of keyword if it is an object of the book class. If it is, then you will need to convert this into an object of the book class, and then we will be able to perform a comparison of these two objects, the first book and the second book. So you can try this, and maybe put your questions in the questions on the KCMS or maybe on the Piazza page, and we see you in the next lecture, inshallah.